Welcome students. In the previous class we actually complete the whole syllabus, okay, that is in your annual syllabus. Now today we are going to discuss, actually we are going to revise the chapter that is force and pressure. Okay, so first of all, just we revise very quick. Okay, first of all, you have to know what is force at first. So the first one is what is force. So force is basically push or pull that acts on a object, and also it produces acceleration in the body, and it can change the speed of the body, and also it can change the direction of motion of a body. So this is basically a vector quantity. Okay, vector quantity means actually it has both magnitude and direction. Okay, now, due to force, we get actually two types of motion. Okay, first one is translatory motion. Okay, and also you can say this is actually linear motion, and the second one, that is rotational motion. Okay, so here we have to know what is translatory motion. Okay, first, motion in which all points of moving body moves uniformly in the same line or direction. This is called translatory motion. Suppose if you take one body which must suppose m, and you just apply a force, okay, in this direction, and you get a motion in straight line. Okay, and body is moved in a straight line. Okay, and the position of body is changed from a point to b point in a linear path. Okay, this type of motion is called translatory motion. Now you can see actually translatory motion is generally seen in rectilinear motion when body moves in a straight line. Example, a car moving in a straight line. Okay, and also you can say a bullet which gets fired moved in a rectilinear motion. So these are the examples of translatory motion. Now, what is turning effect of force? Okay, actually at first you have to know what is turning effect. That means if you take a body like this, and this body is fixed but for a particular point, suppose this point is x, and you apply a force on a body, okay, except the point x. Okay, and also the line of force is some distance, there is some distance between lines of force and the fixed point, that is x. This distance is suppose a. Okay, so here you can say this force, applied force, may cause an object to turn, okay, about a pivot. Here this point x point is called pivot. Okay, so when a body is fixed at a particular point, the point is called pivot, and you apply a force except pivot. Okay, then the distance between, actually if you find out, actually moment of force means the product of force and the perpendicular distance between pivot and line of force. Okay, so here you can say moment of force is equal to F into this distance. Suppose this is distance A, so F into A, okay, is moment of force. Due to this moment of force, actually we get turning effect of force, and you can say that the moment that acts about a pivot in a clockwise or anti-clockwise direction, it may be positive or it may be negative. Okay, it depends on the direction in which we get the turning effect. Now, what are the examples of turning effect of force? Okay, in our daily life we can see, okay, different types of examples that have turning effect. So first of all, we can take a person pushing a swing will make the swing rotate about its pivot, and also you can say a worker applies a force to a spanner to rotate a nut. Okay, a person removes a bottle screw by pushing down the bottle opener lever. Here also you can find out the turning effect, and also you can take a force is applied to a doorknob and the door swings open about the hinge. Okay. Now, what are the factors on which moment of force depends? Basically, the first factor is actually magnitude of force that is applied to a body, to the body, and the second one is the distance between line of force and the axis of rotation. So these are the two factors, and also you can say this is also a vector quantity. That means it has both magnitude and direction. Now the question is, what is the SI unit of moment of force? Actually, you know the actually formula of moment of force. Moment of force means force into displacement. So you can take as force means Newton, and whereas displacement means actually meter, so you get SI unit is Newton meter. And what is CGS unit? CGS unit actually dyne, and dyne into centimeter. Now actually you can see these units are similar as work. Okay, and here in for work part also you can take actually work is equal to force into displacement. Now what is the difference between work and moment of force? Actually you can say that for work actually it is a scalar quantity, whereas moment of force is a vector quantity. That means for work there is no rotational motion or there is no turning effect, but for moment of force we can get turning effect of force, and also we can get rotational motion of a body through a fixed point that is called pivot, or through about the axis of rotation. So this is the actually simple okay short discussion on force, and also discussion on two types of motion, turning effect, moment of force, some examples, and what are the factors on which moment of force depend. Now we move our next point, that is pressure. Okay, before going to discuss the term pressure, we just find out what is the relation between these two units. Okay, one is Newton meter and another one is dyne centimeter. Simply you can say 1 Newton meter is equal to 1 Newton into 1 meter, and also you can say 1 Newton is equal to 10 to the power 5 dyne into 10 square centimeter. So the final answer is you get 10 to the power 7 dyne into centimeter. So this is the relation between SI and CGS unit of moment of force. Okay. Now we move our next point, that is what is pressure. Okay. So first actually we have to know the definition. Simply you can say the perpendicular force per unit area, or the stress at a point within a confined fluid. Actually stress means we can say force per unit force per unit area. This is called stress. Okay, and also you can take as pressure for a liquid or for a fluid part. So you can write down pressure P is equal to perpendicular force, that is called also thrust upon area. Okay, and what is the SI unit of Pressure, simply you can say thrust means force means Newton per meter square. This is called Pascal. Okay, and here you can say in SI system pressure is measured in Pascal unit. Okay, and 1 Pascal is equal to 1 Newton per 1 meter square, and also you can take that 1 atmospheric pressure is very close to 100,000, okay, pascals. Okay, and now the question is, what are the applications of pressure? Okay, simply there are, in our daily life there are several number of applications of pressure. Okay, we just here show some applications of pressure. So first one is actually syringe are used to take blood from for blood test. Okay, due to pressure actually liquid or blood is easily moved into a syringe. Okay, now the next one is when air is sucked out of a drinking straw, the air pressure inside, if it decreases, okay, otherwise when atmospheric pressure outside forces the liquid go inside with a straw. And next one is air pressure in a car tire supports the weight of the car. Okay, shaking a drink through a straw, fluid flow because of pressure difference between 2 points. And now the next one is aircraft fly between of the air pressure of the on the swings. Okay, on the wings. Okay, actually you can take different types of pressure, and just using different types of pressure we just make different things. And also you can take bullet fired from a gun is driven by gas pressure. Toy balloon inflates because of air pressure inside. Okay, so now we move the next one, that is pressure exerted by liquids. Okay, if you take a liquid column and you find out that actually at the bottom point of liquid column is pressure is very high. Okay, because actually pressure depends on three factors for liquid column. In general equation is P is equal to, you can see, H rho into Z. That means H is the depth or height of the liquid column for a particular point from the upper surface of liquid, and rho is the density of the liquid, and G is the acceleration due to gravity. On these factors the pressure of a liquid column depends. So that is why we take different types of examples also. Okay, here you can say that, for example, the pressure acting on a dam at the bottom of a reservoir is greater than the pressure acting near the top. That means if we go down for a dam, then the height or depth increases. That is why pressure of liquid or water is also increases. Okay, that is why we made the dam at the bottom, the broadway, in the broadway, or the width of the bottom of a dam is more, okay, or is greater. Now what are the characteristics of liquid pressure? Simply you can say the first one, liquid pressure increases with depth. Liquid pressure remains the same in all directions at a given depth. Liquid pressure depends upon the density of liquid, and liquid exert pressure on the sides of the container, and a liquid seeks its own level. Now actually to calculate liquid pressure we use a instrument, that is manometer. Simply you can take a manometer, that is a device that measures air pressure using a container with a U-shaped tube. Okay, open one end or both ends. Sometimes you take a manometer or U-shaped tube, that is one end is open. Okay, and sometimes you take U-shaped tube that have actually both ends open. Now you in the next slide you can see that this is the simple block diagram of manometer. Okay, so here just see that there this is U-shaped tube and both ends are opened. Okay, there is a scale, this is your scale. Okay, and in the left hand actually you can shape where actually this pressure to be measured, and in the right side we use atmospheric pressure. But here you can see that the liquid level or the level of liquid is in different height. That means the layer is in different height. Okay, and h is the height, that is the difference between two liquid column or two sides. And if you find out h, then simply just you put in equation p is equal to h rho g. Here h is the height, okay, and also rho is the density of the liquid that is used in manometer, and g is the acceleration due to gravity. Okay, using this relation you can easily find out the pressure that is to be measured. Now the next part, that is the Pascal law. Okay, Pascal law, actually Pascal law states that if some pressure is applied at particular any point of incompressible liquid, then same pressure is transmitted to all the points liquid on the wall of the container. Okay, the pressure of liquid exert the force normal to the surface. Suppose if you take one container like this is suppose your container, and you take inside a liquid, inside this container you take a liquid, and you can say that actually if you suppose pressure is given for a particular point, all also you can say that the pressure is distributed in all direction and pressure act on the all surface of the container. Okay, so this is the simple Pascal law. Okay, and also what is atmospheric pressure? Simply you can say atmospheric pressure is the pressure exerted by weight of air above at any point on the earth surface. And these are the some common uses of air pressure, okay, in our daily life. Simply you can say that operating barometer, okay, and drinking through straw, playing music with wind instrument, okay, inflating tires, breathing, okay, blowing up balloons, okay, flushing toilets, and drawing water from oil. So these are the some common uses of air pressure, okay, that is generally used in our daily life. Now we move another actually instrument, move to another instrument that is actually used to measure pressure, atmospheric pressure. This is called simple barometer. Okay, it consists of a long glass tube, okay, closed one end and open at the other end, filled with mercury. Okay, and also you can take the barometer works by balancing the mercury in the glass tube, okay, against the outside air pressure, and just like a set of scale. Here you can see that this is the simple barometer, okay, and this is glass tube, and you can see that this is glass tube, and inside this glass tube you can see this is mercury. Okay, due to atmospheric pressure, actually some mercury rise in the tube. Okay, and just you have to find out this height. Okay, that is actually occurred due to atmospheric pressure. If you find out the h, then you can simply use the relation, same relation, P is equal to h rho g, and find out actually pressure. We can find out the pressure of atmosphere. Now what are the advantage using mercury in a barometer? If we actually cannot use water, okay, as a barometric liquid, in generally we use mercury in simple barometer, okay, as barometric liquid. Why? Because mercury is the most heaviest liquid. That means therefore it rises to a height only 76 centimeter to balance atmospheric pressure. Otherwise, if you take water, then it may be 1 meter. Okay, one sorry, I think 10 meter. Okay, and another point is actually for mercury it gives more accurate reading as it does not stick to the glass. Whereas if you take water, then it easily stick to the glass. That is why we cannot find out more accurate reading. And also mercury is opaque, shiny, hence it can easily seen through glass tube. Okay, and also you can say the boiling point of mercury is very high. Okay, that is why in the summer season we have we have no problem, okay, with this mercury. Now actually a simple barometer has some drawbacks. So these are the drawbacks. Actually simply first you can take, it is not transferable. Okay, and there is no protection to the glass tube used in it, and the container is open. That is why there are some chances of spilling and impurities getting mixed. So these are the simple drawbacks of a simple barometer. Okay, so to remove the drawbacks we can use aneroid barometer. Simply it is an instrument for measuring air pressure, okay, without any liquid. Okay, and in aneroid barometer uses a small flexible box that is called aneroid cell. Okay, basically which is made of an alloy beryllium and copper. And you can see the diagram of aneroid barometer. Here there are actually 3 point. One is metal box and another one is lever system and another system that is pointer. Okay, so this is the block diagram of aneroid barometer. And in the metal box, that will expand when atmospheric pressure is low, okay, and contract when atmospheric pressure is high. Okay, and with this contraction or expansion, actually expansion and contraction of the metal box due to change the atmospheric pressure will accurate the lever system. Okay, and with this lever system, actually the movement of the lever system will move the pointer and hence giving a reading. So these three systems are connected, mutually connected with each other. So first one, metal box, it will expand when atmospheric pressure is low and it will contract when atmospheric pressure is high. Okay, and for this expansion and contraction of the metal box due to this change atmospheric pressure will accurate the lever system. Okay, and the movement of the lever system will move the pointer and we get a reading. Okay, and using aneroid barometer we can find out or we can measure altitude also. Okay, which is named altimeter. So this is actually the simple, this is the end of actually today's class. Okay, today we just revise the whole chapter. Okay, so this is the end. In the next class we discuss another chapter. Okay.